Next, we're going to look at the horizontal asymptotes of a rational function. So we have a rational function right here. Notice we have an x in the denominator, okay? And that's kind of what gives us a clue here that this is rational, okay? So we're going to look at how to find the horizontal asymptotes if they exist. So here's the graph of x plus 3 over x plus 2. Do you see the horizontal asymptote? Hopefully you notice the asymptote right here that splits the top part of the graph and the lower part of the graph. Splits them in two pieces. Right here at 1. Y equals 1. So we're going to learn how to find this horizontal asymptote today. Okay, I know you can read, but let's go through this. If f of x equals n of x over d of x, n for numerator, d for denominator, if the two polynomials have no common factors, then the graph of f of x has at most one horizontal asymptote. Okay, so here's how you find your horizontal asymptotes. If the degree of the numerator, the function in the numerator, is less than the degree of the function in the denominator, then the line y equals 0, which is the x-axis, is the horizontal asymptote. Okay? The degree, remember the degree represents the largest exponent. Okay? So we have to look at the degrees of the two polynomials. For example, the degree of the polynomial in the numerator is 1. That's the biggest exponent in the numerator. The degree of the polynomial in the denominator is also 1. So does that fit this condition? The degree of the numerator function is less than the degree of the denominator function? No. No. Okay? Second condition. If the degree of the polynomial or the function in the numerator is equal to the degree of the denominator function, then the line y equals a over b is the horizontal asymptote, where a is the coefficient of the highest powered variable of the numerator, and b is the coefficient of the highest powered variable of the denominator. Okay, well, let's see. So we're looking to see if the degrees are equal. So going back up here, all right, the degrees are equal to each other. So we use the coefficient of the highest powered variable in the numerator, which is 1, and the coefficient of the highest degreed powered variable in the denominator, so 1 over 1. So the equation for a horizontal asymptote for this is going to be y equals coefficient over coefficient, or y equals 1. And there it is. That's what we found earlier, y equals 1. If the degree of the numerator function is greater than the degree of the denominator function, then the graph has no horizontal asymptote. So let's go ahead and turn the page and let's look at some examples. We might have to turn back and forth until we have these memorized. It says find the horizontal asymptotes of each of the following. So remember, we're looking at the degree. Okay, we're looking at the degree, which is the highest exponent. We're comparing them. So in the numerator, our degree is 3, and in our denominator, the degree is 2. Well, 3 is greater than 2. So, looking back, here it's less than, here it's equal, here it's greater than. So what kind of asymptote? No horizontal asymptote. So I'm going to write none. There is no horizontal asymptote for this function. Okay, next one. The degree of the numerator, 1. The degree of the denominator is also 1. Okay, so since 1 equals 1, the degrees are equal. And I want you to memorize these rules. So looking for equal, so that means we're going to put A over B to get our horizontal asymptote. Okay? So y equals, sorry, this is kind of crooked. A, that's going to be the coefficient on the highest powered variable. So we're going to have 2 over 1. So y equals 2 is our horizontal asymptote. All right, number 3, the degree of the numerator is 1. Okay, the degree of the denominator is 2. So 1 is less than 2. Okay, so less than right here. Okay, the line y equals 0 is our horizontal asymptote. All right, let's look at number 4. Okay, so since the variable is missing in the numerator, we're going to use 0, okay, for the degree of the numerator function. And then the degree of the denominator is going to be 1. So 0 is less than 1. So we're looking at less than. We just had a less than, so it's going to be y equals 0. Okay, so if some of you are wondering where am I getting the 0 from, because you don't see any exponents here on a variable, if I plug in an x here, okay, I would put that to the 0 power. And remember, anything to the 0 power is 1. So the x is gone because it's raised to the 0 power. It became 1, and then 1 times 3 is just 3. Okay, so when the variable is missing, the degree is 0. All right, it says find the domain, the vertical asymptotes, the horizontal asymptote, if one exists for each of the following functions. So we're kind of spiraling what we learned in the last video and this video together. So domain is going to be, remember, all real numbers. So x is an element of all real numbers such that x does not equal, and remember we take that denominator, we set it equal to 0, and solve for x. So x equals -2. So that means we have a vertical asymptote at -2. So the graph does not touch -2, so it is not in the domain. And vertical asymptote, x equals -2. Okay, horizontal asymptote, the degree of the numerator is 1, the degree of the denominator is 1. They're equal to each other. So if we go back up here, remember when they're equal, we do a over b. So we're going to do 1 over 1. So y equals 1. Okay, go ahead and try number 6 on your own. And let's go ahead and move down here. It says identify the horizontal and vertical asymptotes from the functions graph below. So here we can draw in our horizontal pretty easily. You just find that line that cuts the two in half or splits them up. So that's going to be 1, 2, 3. So y equals 3. Vertical asymptote, Might be a little bit harder here because we're trying to get right in the middle of these two functions. Kind of difficult here. I'm going to go ahead and draw this in. I want to go directly in the middle of these two. So it looks like this vertical asymptote is going to be in the middle. So that's going to be -1, -2, -2.5. So x equals -2.5. We're looking for a line that cuts it in half. So left from right, vertical asymptote. Top from bottom, that's your horizontal asymptote. Now notice on number 9, number 9 is odd because when it looks like this, notice that neither one of these parts is converging to a horizontal asymptote. It's not converging to a horizontal asymptote. There's no line to draw this way. So there is no horizontal asymptote. Okay, there's none. But there is a vertical asymptote because it is converging up here and it is converging down here. Okay, it's converging to this line, it's converging right here. So that's going to be x equals -1. So when it looks like this, none, but they do have vertical asymptotes right here. It does have a vertical asymptote. Okay. You try number 10. Let's look at 11. Number 11 has a couple verticals here. Okay. X equals 2 and x equals -2. Now, you may think there's no horizontal, but there is. This is the function where the graph can cross a horizontal asymptote. The horizontal asymptote is going to be right here because notice this part of the graph is converging or getting closer to the x-axis. So it does, even though it crosses here in the middle, these two ends are getting closer and closer and closer to this horizontal asymptote. So it's going to be y equals 0. So remember, so the rule is that with asymptotes and rational functions, which is what we're studying right now, rational functions, they can never, ever, there's not a situation where they will ever cross a vertical asymptote, never. But they can cross a horizontal. Okay, it's proven right here that it's crossing. Okay, see you guys tomorrow.